When you sit down at a computer, you interact with a highly polished visual language. You find a brightly colored icon on your desktop, you double-click it, and an app opens on your screen. That is the seamless experience designed for the average user. But once that icon shatters, the visual layer disappears. Windows begins processing instructions dictated entirely by the hidden extension of a file name. You usually only notice this underlying machinery when something breaks. It is the moment a game crashes because of a missing file error, or a system gets compromised because a user clicked what looked like a document but functioned as a script. Securing data and troubleshooting a PC requires stripping away the visual interface to see the technical blueprints telling the operating system how to behave. The primary engine driving Windows execution is the .exe file. This is a compiled software program designed to run directly on the operating system to carry out tasks. Its predecessor, the .com file, operated on much stricter limits. Common in the era of 32-bit systems, a COM file could not exceed 64 kilobytes and executed as raw, simple machine code. Modern software is massive and complex. Unpacking and distributing thousands of individual files requires more coordination than a standard executable engine can provide. This is the role of the .msi file. Operating as a relational database, it instructs the Windows installer service exactly where to place every file. Its sibling, the .msp file, uses that same logic to patch an existing installation. Within this system, EXEs function as the engines that drive tasks, while MSIs and MSPs act as the architects that build the environment for those engines to run in. If you play PC games, you have likely run into a specific frustration, a high-end application failing to launch because of a missing DLL error. These files prevent a massive storage problem. If ASINT program had to include its own code for rendering 3D graphics or managing audio, hard drives would fill up with redundant data almost immediately. The .dll, or Dynamic Link Library, provides the solution. It is a shared repository of code. Multiple programs can access a single DLL simultaneously to borrow its functions rather than carrying that code themselves. This modular architecture sacrifices stability for efficiency. If one central DLL breaks or goes missing, every application that relies on it fails at once. Beyond compiled software, Windows uses plain text files to automate tasks. The most common tools for this are .bat and .cmd files. A bat file contains a list of instructions that the Windows command prompt executes sequentially. This allows a user to automate routine tasks, like moving or copying folders, by running them line by line. For more complex needs, Windows supports .vbs and .js files. Written in Visual Basic and JavaScript, these formats allow for advanced logic and can even trigger user interface elements like pop-up message boxes. These scripts bypass the basic command line and run through the Windows script host. This gives them a deeper level of programmatic interaction with the system. Because these are lightweight text files capable of executing powerful logic without a formal installation process, they are effective tools for IT automation and common vectors for malware. We can now deconstruct the desktop environment. The icons you click every day are .lnk or .url files, superficial pointers routing traffic to a destination file or website. One layer deeper into the system configurations, you find .cpl files. These are compiled modules built specifically to launch the various menus and interfaces in the Windows control panel. To reach the settings that govern how the operating system itself operates, you have to look at the .reg file. The Windows Registry acts as the control center of the machine. A reg file is a text structure designed to add, modify, or delete the values stored inside that registry. Modifying the registry changes the machine's behavior at its most basic level. A single incorrect entry inside a reg file can stop the operating system from booting entirely. The ecosystem works in harmony. Pointers launch executable engines, those engines draw resources from shared libraries, and everything is organized by structured database installers. These file extensions serve as mechanical blueprints, dictating exactly how hardware and software must communicate. Learning to read these file types changes your relationship with the computer, effectively turning a passive user into an administrator who understands the logic of their system.